Hello class, welcome back. We are learning chapter 3 today, logical reasoning. So we have learned about the first part of statements. So today we're going to the last part of statements. Alright, this one. Okay, implication. This is something new for you. So we look at this sentence here. If it rains, then the beach trip will be cancelled. So for this sentence here, it is called an implication because they have a if. They have the if and they have the then. Right? So if you see these two words, if something, then something, then it is called an implication. So I'm going to introduce you after the statement, after the if, we usually label it as statement P and we call it antecedent. Then after the word then, this sentence here we usually label it as Q. Then Q, then something will happen. So this something will happen, we call it consequent. Okay, antecedent and consequent. Antecedent will be the one in front, consequent will be the one at the back. Huh? Right, we look at example 8 here. Form an implication if P then Q with the given antecedent and consequent here. So they give you antecedent and consequence, you have to form the implication yourself. K is divisible by 5. K is a multiple of 5. So we know that this is your P statement, this is your Q statement. So you're going to form this. We write the equation then. If K is divisible by 5, then K is a multiple of 5. Okay, it's just very simple here. Next one, we go to another, next one. Antecedent set K is a subset of set L. Okay, we can refer to this diagram here. Set K is a baby set of set L. Yeah, meaning that K is inside this big set L. So, consequence here, number of K, meaning the numbers, the values, the elements inside K is less than the number of L, which is also correct, huh? Because for L, for this set L, we have 1, 2, 3, 4, 5, 6, 7. Let's say we have 7 elements inside, but for number inside your set K, there's only 3 elements inside, which is less than. Correct? No? So you have to form an implication from these two. If set K is a subset of set L, then number of L is less than number of K is less than number of L here. Okay. Example 9, determine the antecedent and consequence for the following implication. If P, then Q. So they ask you which one is the antecedent, which one is the consequence. So this is also very direct question. If X is a factor of 16, then X is a factor of 64. Okay, where is the antecedent? After the word if, which is this. This is your antecedent. And your consequence is after the word then. Here, this is your consequence. Okay, so answer. Antecedent, X is a factor of 16, consequent X is a factor of 64. Okay, now we have another type of implication. Okay, that type of implication is a little bit different from the previous type because it will be like this. And you will always see this word if and only if. P, if and only if, Q. Look at this example, yeah. I wear my hat if and only if it is sunny. This is a new type of implication here. So this type of implication, if you see this if and only if, meaning that it is consisting of two implications. From here, you can write down another two implications from this statement, which is these two. If P, then Q. Or if Q, then P. You can write down two implications here. Okay, so let us find out where is your P and Q first. So if and only if, the first part here is your P. And second part is your Q. So implication 1, you can write it here. If I wear my hat, then it is sunny. Okay. Another implication that you can write, if it is sunny, then I wear my hat. Remember, yeah, when you see this word if and only if, you have and you must form two implications out from here. If you only write one of it, meaning it is not correct, you won't get marks here. Huh? It must have two implications. Example 10, form an implication P if and only if Q with the following implication. If K is a prime number, then K has only two factors. Then they also give you another example. If K has only two factors, then K is a prime number. So from this, what do you notice? This is your P, this is your Q. Huh? And this is your P, this is your Q. And these two are the same statement. Meaning you can form an implication here. Combine these two, it will become K is a prime number if and only if K has only two factors. Okay. Then go to example 11. Write down two implications based on the implication P if and only if Q. So when you see this word, meaning you can form two implications out. First, we have to do bracket. First, you bracket your P and Q. This is the implication if and only if. The one in front, the statement in front is your P, and the statement at the back is your Q. Okay, then you are going to form your implication 1. If square root of R is 15, then R equals to 225. Implication 2. If R is 225, then square root of R is 15. You must show two implications out. Okay, the next one. So you also see this word if and only if. So you quickly bracket the one in front, the statement in front, x less than 6 if and only if x plus 10 less than 16. This is your P, this is your Q. So you write down two implications. First one, if x less than 6, then x plus 10 less than 16. Second, if x plus 10 less than 16, then x less than 6 here. Okay. This is something new for you also. Converse, inverse, and contrapositive. Okay. Previous syllabus, we only learned until converse, but the new syllabus KSSM, you have more to study. Inverse and contrapositive. Okay. This is the general format, yeah? So we are going to look at one example here. If Ali is a prefect, then Ali is a disciplined person. So I want to bracket this. After the if, this would be your P statement. After the then, this will be your Q statement. Okay? By looking at the general form, if P then Q, yeah. If Ali is a prefect, then Ali is a disciplined person. Then we want to write the converse. If the question asks you to write converse, what will it be? If Q, then P. Meaning these two, they change position, right? The ballet. So the one at the back will become in front for the converse. If Ali is a disciplined person, then Ali is a prefect. Okay? Right. Next would be the inverse. Inverse here, you look. If this is tilde P. Tilde P, remember what does it mean? Negation. Negation of P. If negation of P, then negation of Q. It's still the same P and Q, but they add negation in front. This is inverse. Okay, negation means you add a not or no. So if Ali is not a prefect, then Ali is not a disciplined person. Okay? This is inverse. Then how about contrapositive? By looking at this general form, if negation of Q, then negation of P. Meaning these two, they change position. Okay? So you change the position, the one at the back will become the front. If Ali is not a disciplined person, then Ali is not a prefect. This is a first example. We go to example 12. Okay, we can always refer to this general form, but you have to memorize it. Write the converse, inverse, and contrapositive. So they say if x is a positive number, meaning that x can be 1, 2, 3, 4, and so on. then x is greater than 0, which is true lah. Okay, so the statement is this statement. Just copy down if they ask you to write down. Then they want a converse. Converse means you change the position. If Q, then P. Get it first. This is your P. Then x is greater than 0. This is your Q. So the Q will come first. If x is greater than 0, then x is a positive number. Okay, this is converse. Now, how about inverse? Inverse means you add a negation in front. Negation P, negation Q. So if x is not a positive numbers, then x is not greater than 0. Okay, they added a not. Contrapositive, you change this to position. The one at the back will become the front. If x is not greater than 0, then x is not a positive number. Okay, here. Another example for you. If x equals to 5, then x plus 1 equals to 6. Correct or not, this statement? If x equals to 5, yeah, if x is 5, then you put the 5 in here. 5 plus 1 equals to 6. So this is a true statement, huh? So I'm going to put bracket here. This is my P, this is my Q. Copy down the statement. Then they want to converse, meaning these two, terbalik. The Q will come first. If x plus 1 equals to 6, then x equals to 5. Inverse. Okay, inverse means you negate. Negation of your P and negate your Q. So x equals to 5 will become x is not equals to 5. If x is not equals to 5, then x plus 1 is not equal to 6. Equal sign become not equal is this. And contrapositive means you change the two position here. If x plus 1 not equals to 6, then x not equals to 5. Okay? Alright. After we learn that, we also have to learn the keyword, a counterexample. What does a counterexample mean? Okay, we look at here. All polygons have 2 or more diagonals. Is this true? We look at these two polygons, yeah. One is a triangle, one is a rectangle. So diagonals is from this vertex. From this vertex to another vertex, you can form a line. This is called diagonals. You can also from this vertex connect to another vertex. You can form a line. These are called diagonals. Okay? But how about the triangle? From this vertex, you want to join this vertex. You join them. You can't form any diagonal because it's at the side of the triangle. Right? So for triangle, there is no diagonal at all. So this is a false statement. So when they say give a counterexample, means you have to give one example to support your false. Counter example is the triangles do not have diagonal. This is one example. Okay, example 14 now. Determine the true value of the following. If it is false, give one counter example to support your answer. So the sum of interior angle of all polygons is 180. Okay, you want to find the sum of interior angle. This is a formula that you have to remember. N minus 2 times 180. So n is the number of sides here. So for triangle, yeah, 3 sides, right? 3 minus 2, 1. 1 times 180, yeah, you will get times 180, you will get 180 still. Yeah, the sum of interior angle of a triangle is 180. But how about this? Rectangle, we have 4 sides, isn't it? 4 minus 2 times 180, you get a 360. So the interior angle is already becoming 360, right? So we know this is a false statement because the sum of interior angle, they give an example of a pentagon. Pentagon is 5 sides. 1, 2, 3, 4, 5. 5 sides. 5 minus 2 times 180, you get 5, 4, 4. Okay, they give example of pentagons. Of course, you can give example of a quadrilateral. We call it quadrilateral or a rectangle, or square. Okay, next one. 4 and 8 are the factors of 20. Factors means the two value times together you get 20. Yeah, correct. 4 times 5 you get a 20, right? 8 times what? You get 20. Cannot, isn't it? So 8 is not a factor. So this is a false statement because 8 is not a factor of 20. This is your counter example here. Okay. So here, we go to example 15. So they ask you to write the mathematical statement requested in this bracket. They want you to do negation here, then determine the truth value of each statement written. Okay. 6. Or if it is false, give one counter example to support your question. You have to change it first, then you will have to identify whether it's true or false. Then you give one a counter example if it is false. Huh? Okay, 6 is the element. This symbol here means element of the set 369, which is correct, huh? 6 is the element of 369. 6 is inside here. So when they ask about negation, it is 6 is not equal, not an element of 369. Right? Is this true? Now this is true, right? So when you negate it, the statement will become false. So if it is false, give one counter example. Why is it false? Because 6 is the element of this set. Right? So this is your answer. 6 is an element of 369. This is your counter example. Okay, now they ask you to write the converse of this. So we can refer. When you want to write converse, means the one at the back will become the front. If x more than 3, then x more than 5. Is this a true statement? So we look again. Jikalau x adalah lebih daripada 3, maksudnya your x can be 4 or 5 or 6 and dot. Then x will be more than 5, correct or not? It's not correct, isn't it? Because x can be 4. 4 is less than 5. So this will become a false statement. False statement because why? Because you can show example 4 is more than 3, but 4 is less than 5. This is an example. Okay. Next one, if x is a root of x cubed minus 1 equals to 0, then x is 1. Write the inverse. Inverse, negation of p, then negation of q. So when you write the inverse is if x is not a root of x cubed minus 1 equals to 0, then x is not equals to 1. True or not? If x is not a root of x cubed minus 1 equals to 0, then x is not equals to 1. This is a true statement. So if it's true, then no need to give counterexample. Okay, next one, if k squared more than 0, then k more than 0. So they ask you to write the contrapositive, negation of q, then negation of p. So how do you write? If negation of q first. This is your q. If k, okay, this is more than. If you want to do negation, you do the opposite. You have to change the symbol here. Less than or equal to 0. Then k squared less than or equals to 0. Okay, so we see whether this is correct or not. Okay, if k is less than or equals to 0, let's say we choose a negative 3. If k, okay, if negative 3 less than or equals to 0, right, then you put negative 3 square it. You have to square the negative together. It will become positive 9. This is more than 0, right? It's not less than 0 anymore. So this statement is false, and the counter example is here. Just show why is it wrong. Okay, so this is what you need to do, yeah, for today. Your textbook. Okay, happy learning class. Thank you.